Okay, so we're going to talk about electric current, and we're focusing in and thinking about what's happening inside a wire when electricity is travelling through that wire. And so the thing that actually carries electric current, we know now, are the electrons moving inside a wire. But unfortunately, when we first started experimenting with electricity, people didn't know about electrons. Like, they discovered electricity 100 and something years before they discovered electrons. And so we think about current flow as going the opposite way to electrons. We know that electrons are little negative charges that flow through a wire, but when they were first theorising about electricity, they were theorising that, it must be positive charges flowing through the wire. Why would it be negative ones? And so that's where we've got our current travels the opposite way to what electrons actually travel. And so what is current? Current is the rate, like the speed at which charge travels through a wire or around a circuit. So if we're defining it, current is equal to charge per time. We often just measure current with an ammeter, but we can actually go back to like the fundamentals and think about what current actually is. So charge, hopefully we remember that it's measured in coulombs. Time is measured in seconds, and so electric current, we could measure it in coulombs per second, but much more commonly you're going to see it measured in amps, and the symbol we use for amps is capital A. So electric current is the rate at which electric charge travels around a circuit. Like how many electrons, well, it's not quite how many electrons, but it's proportional to how many electrons go past a fixed point